Hello biology, this is Mr. B. We are going to continue on with section 1, and remember it is titled What is Science? So we're looking at the second part of that. Just a quick reminder of what we talked about last time. We mentioned what science kind of is and isn't, and how it mainly focuses on things in the natural world. And one of our main goals of science, once we figure out how those things apply to the natural world, we look for patterns and we look for ways to connect them to make predictions about the future. So now, when we talk about science, we're going to talk about what we call scientific methodology, and which is basically at the heart of science because it's the procedures that we need to use to actually be proper scientists. So if we find an issue or a problem that we want to investigate, there's certain steps, or again, the fancy term methodology, that we have to follow in order to make sure that our results are 100% accurate and not skewed in any way. So it involves several steps, which include, and I would not write these all down now because we're going to get them all here in a second. It involves observing and asking questions, making inferences and forming hypotheses, conducting controlled experiments, collecting and analyzing data, and drawing conclusions. So we're going to kind of take a step-by-step walk through an actual experiment to kind of give you an idea of what each one of these steps entails. So our first step always begins with observation. And so again, like it just says there, scientific investigations begin with observation, which is the act of noticing and describing events or processes in a careful, orderly way. So our example that it gives us is that researchers observed that marsh grass grows taller in some places than others. And this observation led to a question: why do marsh grasses grow to different heights? And my text got a little bit cut off there, so it probably grows to height in different areas or something in different places. So why do marsh grasses grow to different heights in different places? So again, researchers walking around see two different locations, exact same marsh grass, and they wonder why location A has shorter grass than location B. That's their observation. Their observation, again, almost leads directly to a question. If you make an observation and then don't ask a question, then you're not really thinking like a scientist. So that's the first step, observation and asking questions. Again, they seem to go hand in hand with one another. So after you have posed your question, you're going to further your observations to make an inference, which is a logical interpretation based on what is already known. So again, an inference, if I came to school and I had a big green stain on the front of my shirt, you might be able to infer that I tripped and fell as I was walking in that day. And then your inference then can lead to what is called a hypothesis, which is a scientific explanation for a set of observations that can be tested in ways that support or reject it. So maybe then your hypothesis is that Mr. B tripped and fell as he was walking in because someone kicked a soccer ball underneath his feet. So that would be your hypothesis. So an inference is kind of just like you making the guess there, or making an idea of what had happened. A hypothesis is kind of a more specific scientific explanation for what has happened. Again, in the past you might have just used the word educated guess, but for now, since you guys are all big-time biologists now, we have to use that it's a scientific explanation for a set of observations. And after we have formed our hypothesis, we're going to have to stick with our example here. So our examples are, again, we're talking about the marsh grass still. Our researchers inferred that something limited grass growth in some places. Again, so there had to be a reason why A was shorter than B, so they inferred that there was something there that made that change. So based on their knowledge, they hypothesized that marsh grass growth is limited by available nitrogen. So another good kind of way to tell the difference between an inference and a hypothesis is that a hypothesis is actually much more specific. An inference is kind of like the first step, like, oh yeah, something has to be there, and our hypothesis is more specific, saying that the nitrogen being available in one spot versus the other is going to affect the grass growth. So that's the difference, again, between our hypothesis and an inference. And after we have, again, hypothesized and made our inferences, we are actually going to test it. And we test it by designing an experiment that keeps track of various factors that can change, or we call them variables. So a variable is a very important word, and people get confused about variables, so I'll go over these again in class. So a variable is any factor that can change. So a factor that can change is a variable. That is a very important piece of information that you need to know. An example of a variable could be something like temperature, light, time, and availability of nutrients. So whenever possible, a hypothesis should be tested by an experiment in which only one variable is changed. So that, again, in the past people have gotten tripped up on this, but only one variable is changed when we do a correct experiment, a controlled experiment. So our example would be if we want to test, or if we want to look at these factors, we can only change one of those at a time. So we can't change temperature if we're changing light. So if we want to test light, we expose one salt marsh to light for 12 hours. We expose the other one to light for only 3 hours. We leave everything else exactly the same. And so when we leave all those other variables unchanged, we keep them what is called controlled. So this is called a controlled experiment. So a controlled experiment is an experiment which only one variable is changed. That is a huge, huge, huge thing here in biology and in science in general. So we're going to talk more specifically about those variables that we need to control. So it is important to control variables because if several variables are changed in the experiment, researchers can't easily tell which variable is responsible for any results they observe. So for example, if you give one plant 12 hours and then you water it 3 times a day, and you give one plant 12 hours of sun and you only water it once a day, then again we're not going to be able to tell what is actually causing the change. So when we talk about our variables, we have a variable that is deliberately changed, so that is our independent variable. So the one thing that stays the same, it is independent of everything else. Or I'm sorry, forget what I just said. So the one that is deliberately changed, it does not stay the same. It is the independent variable, or some people like to call it the manipulated variable, because manipulate and change mean pretty much the same thing. So if you manipulate the variable that is being changed, so again, our example, we only are going to change the amount of water that we give. We leave everything else the same. And so then the variable that is observed and that changes in response to the independent variable is called the dependent variable. So that's also called the responding variable. So if our plant that, again, we only water once versus 5 times a day, where we leave everything else the same, and then we notice that it grows 10 feet compared to one only grows 1 foot, then that is our responding variable. So that is a big, big key there when we talk about setting up our controlled experiments. And typically an experiment is divided into 2 groups. Our control group is exposed to the same conditions as the experimental group except for one independent variable. So what that means is we have one group where we leave normal, so we don't really do anything to it. We just keep it the same, we keep the normal conditions like it would just be in nature, and so when we make the changes in our other group, we can kind of see what is actually responsible for what is going on. So I will explain this more in class. I know that might be a little bit confusing to some of you, but don't worry, just know, probably take away, again, what an experiment is, maybe what a variable is, and things like that. So if you have any questions, make sure you write them down and let me know.